Hey everybody. So today in class we worked on turning verbal phrases into mathematical expressions, right? Taking words and turning them into math. Tonight we're going to work on something similar, but instead of expressions we're actually writing equations and inequalities. So statements that compare one expression to another. Let's start by talking about some vocabulary. An equation is any mathematical statement that compares two expressions using an equal sign. Basically, if you see an equal sign, you're working with an equation. An inequality compares two expressions using a greater than sign, less than sign, or a greater than or equal to, or a less than or equal to signs. Yesterday in our notes we saw that certain key words indicated that we needed to use certain operations. If we saw difference, we knew we needed to use subtraction. If we saw quotient, we knew we needed to use division. The same thing happens when we're trying to write equations and inequalities. There are certain key words and phrases that tell us which symbol we're going to use to compare the two different expressions. For instance, if we see the phrase the same as or the phrase is equal to, sometimes even just the word is, that lets us know that we should use an equal sign between the two expressions. If we see fewer than or less than, that lets us know that one expression is less than the other. We want to use a less than or equal to sign when we see the phrase at most. For instance, if somebody says, I have at most $50, that means I can have equal to 50 or less than 50. So that's less than or equal to. Greater than is pretty obvious, something that says more than or greater than. Greater than or equal to is usually indicated by the phrase at least or no less than, right? If I say I ate at least 5 cupcakes today, that means I had equal to 5 cupcakes or more than 5 cupcakes. So I would use greater than or equal to. If you need to pause it here to write down this information, that would be a good idea. All right, let's check out some examples. In example A here, it says the difference of twice a number k and 8 is 12. So the difference of twice a number k and 8. I know I'm going to have some subtraction in here because of difference. And I see it says twice a number k. So I know that twice a number is 2 times that number, so I have 2 times k minus 8, because it's the difference of twice a number k and 8. And then here it says is 12. And that's what we're focusing on today. Is 12 means that that is equal to 12. 2k minus 8 is the same as 12. Let's check out example B here. The product of 6 and a number n is less than 24. I'm going to use a different color here. So it says the product of 6 and a number n is at least 24. So product means multiplication, and I'm multiplying 6 by n. So 6n is at least 24. So I'm comparing it to 24. And at least, remember again, that means greater than or equal to, right? 6n can be equal to 24. It can be more than 24, but 24 is the least it can be. So it can't be any less than 24. And example C here says a number y is no less than 5 and no more than 13. So here I actually see two types of comparisons. A number y is no less than 5. So I know y can't be less than 5. Y has to be greater than 5 or can be equal to 5. And y can be no more than 13. This is a tricky one. Sometimes when we see these two comparisons in the same statement, we can write out our inequality with two inequalities. And this is saying that y is somewhere between 5 and 13, right? It's no less than 5, so it could be 5 or higher, or it could be 13 or less, because it can't be more than 13. So that's how you write equations and inequalities from verbal phrases. We just have one more thing we're going to cover, one more skill we're going to learn today. But before we get to that, we have to cover a couple more vocabulary words. The first one is open sentence. An open sentence is an equation or inequality that contains a variable. So an example could be 2x plus 7 equals 12, or 3y squared minus 10 is less than or equal to 18. Both of these are open sentences because of the variable. We don't know if this equation is true, and we don't know if this inequality is true until we know the value of the variable in each one. A solution is any value that can be substituted for a variable to make an open sentence true. So if my open sentence was 3 times x plus 5 equals 17, 4 is a value that would make this true, because 3 times 4 is 12, plus 5 gives me 17. So we would say 4 is a solution. Right? Now if I used 2 here for x, that would not be a solution. 3 times 2 is 6. 6 plus 5 is 11. So because 2 doesn't make this equation true, 2 is not a solution. All right, let's do one last example. Here I want to know, is n equals 3 a solution for 5 plus 3n is less than or equal to 20? So I can find out by substituting. 5 plus 3 times 3 is less than or equal to 20. Is this true? We'll do our order of operations. I'm going to multiply first before I do my addition. That's a 9, believe it or not. Just taking it one step at a time, and now I'm going to do 5 plus 9, and I get 14 is less than or equal to 20. So by substituting n equals 3, I got a true statement, a true inequality. So the answer here is yes. N equals 3 made this statement, this original statement, true once we calculated it all out. And our last example, is n equals 6 a solution? And we'll use the same inequality up there. I have 5 plus 3 times 6. I'll do my substitution. I'll rewrite my inequality. 5 plus 18 after I do my multiplication. And now I add, that's my last step. I have 23 is less than or equal to 20. Now this is not true. So because this is not true, n equals 6 is not a solution. So is n equals 6 a solution? No.